Okay, hello class. Another fun video on linear modeling. Yay! Okay, in this one, instead of being given a table, this problem, as you can see below, or these types of problems, are much easier. It's the same thing that we've been doing in that we are coming up with equations, we are evaluating those equations and answering questions about them. But in this case, we're going to introduce two new things. One, we're going to name the variables. It makes more sense when you're writing an equation, given a word problem, to name the variables about something that's going on in the word problem. This way you can very easily understand which one is y and which one is x. So we'll look at that in a moment. And then also we want to use function notation. We learn function notation. It's something you're going to see when you're doing more linear modeling problems in physics and also later on. So you want to get used to this notation. Okay, so let's take a look. First step, your school band wants to buy new recording equipment. The band has collected $1,200 in previous fundraisers. If the band sells sandwiches at $5 each, how many sandwiches will they need to raise the remaining funds? So we want to write an equation, we want to name the variables, and we want to use function notation. Yay. Okay, so step one, identify the independent and dependent variables in the model. Name the variables with a letter logically from the body of the problem. So what does that mean? We are taking a letter and we are naming the independent and dependent variables. So let's start with that first. Let's look at what the independent and dependent variables could be. Okay, so we're selling sandwiches at a profit and we're selling them at $5 a piece. In this case, the independent variable is the amount of sandwiches, right? So let's put that down here. Um, Sandwiches. Right. Excuse the horrible handwriting. And then also for the dependent variable, what could that be? Well, I think that that's the profit. The amount of sandwiches we sell depends, okay, on how much money we make, aka profit. Profit is how much money you're making when you are selling something, okay? So, ba, ba, ba. Okay, right. So we need to name these independent and dependent variables, right? So how am I logically going to name this independent dependent variable coming up with a letter? Well, easy. Sandwiches. I'm going to choose S. The dependent variable, profit. I'm going to choose P. Note that for the dependent variable, I have an uppercase P, okay? And then for the independent variable, S, I have a lowercase letter. That is the notation. You'll see that, how that works a little more in 1 second. Okay, so we'll do the same thing we did before. I'm going to scoot through this because you should know how to do this. You're writing the independent and dependent variable using using their units. So here we go. We identified the dependent variable being profit. So that's the change in profit over the change in sandwiches, meaning the more sandwiches I sell, the more profit I make. That's how we're interpreting it as a rate of change. Okay, so now we need to identify the sloping initial value from the body of the problem. This is using these rate buzzwords is really the easiest thing to do. I think finding the rate is somewhat easier. Remember the buzzwords that we've gone over. So let's write them down if you don't have them. I think I might have only even identified a couple of these. Um, so let's, in the last problem that we did. So over, that's a good one. If you're using the word rate, of course, that means the rate. Every, every is one. That's a good one. Each, the word each. Um, per, that's probably the most common one, per. So if you see any of these words around a number, all these words mean rate. So in this particular problem, okay, we do have the word each. As you can see, the band sells the sandwiches at $5 each. So given that that's the case, I am going to say that the rate, of course, or the slope is 5. Now, it's really just what's the other number in the problem. That's a good way to think about it. But it makes sense that $1,200 is my initial value in this problem, and that's B. And why? It makes sense because we start out with $1,200 and then we sell sandwiches to make up the rest of the profit. So we're starting out at $1,200. Right. Okay, good. Next step. Substituting these letters in for step one into the equation of a linear function. So we identified that y was capital P. We identified that m, that was going to be 5. We identified that x, the letter that we called x when sandwiches, was s. Note the difference between that 5 and s, although you can't see it all that well. But this is an s and that is a 5. And then b, $1,200, right? Okay, so in this final equation, in function notation, remember function notation, if I'm going to write it as f of x with y and b, it would look something like this. So we are writing, oops, let me take this and move that over here, erase that. I had wrote y, but we know that f of x is y, so that doesn't make sense. But if I'm writing this in function notation, then let me just get back to my pen. F of x is equal to, okay, I know my slope. Mx plus b is 5x plus 1,200. But we want to be able to use for f of x and x the variables that we named. So we do that by putting capital P of s. So P of s replaces f of x. The same way that f of x represents the dependent variable, and x is the independent variable, s is the independent variable here, and p is the capital letter outside of the parentheses. So that's how we write that. P of s is equal to 5. Instead of writing x, we write s plus 1,200. Right. Okay, so P of s, capital P of s, is equal to 5s plus 1,200. This is how we rewrite this function from function notation, and we are naming variables capital P and S. Okay. So now we are answering questions about this. So same exact steps that we did before when we were answering and evaluating models. So I'll sort of try to scoot through this, given that that's the case. How many sandwiches did the band sell if they made 1855? So your job is to decide 1855, is that a value of y or x? If you said y, good job. That's 1855. Right, this is the profit, right? I didn't write P and S because we need to sort of make this universal, but note that this is P, capital P, the profit, and that the X is unknown, S. So if I am then substituting the given value from part A into the equation and knowing, and I'll rewrite my equation here. That's capital P of S is equal to 5S plus 1,200. I am given my unknown, or sorry, my known part of the problem in this question. How many sandwiches did the band sell if they made 1855? I'm given that. I plug that in this case for Y, or in our case for P of S. And I'm saying, okay, my unknown is S, my known variable, 1855, and then I solve algebraically for S. Okay, so how do I do that? I'm subtracting 1,200 from both sides, subtracting 1,200 from both sides, and I get 655 is equal to 5x. Divide both sides by 5. Divide u by 5. Divide u by 5. Let me give myself some more room to work here. And my final answer, x, is equal to 131. But wait, that's not my final answer. Why? Here, if you remember, relating my result from step 2 to give my answer using units. So what's my units, quote unquote, here? 131 sandwiches. Right. Okay, good. Final answer, 131 sandwiches. Okay, so I want you to do the same thing in a your turn problem here. naming the independent and dependent variables, coming up with the function and function notation. After you've named the independent and dependent variables, remember to capitalize the dependent variable and make the independent variable lowercase. And then evaluate it as well too and answer a question about it. So that will be our video for today. See you guys in class on Friday.